right, so feel free to keep doing what you were doing yesterday if you like, because like I say, the whole point of this is you can choose to do whatever you find interesting. But anyway, if you want, I figured we'd start with Python today because we need it for a lot of these challenges. And the first part will be very easy, Python setup. There's several online Python sandboxes, and here's one of them in this challenge where you can do simple things, but what you can't do is any network traffic with that because they all don't want you running scripts and attacking people's websites. So once you get that one working, then you want to run Python locally, and there are various ways to do it. You can install it on a Mac, you can install it on Windows, but if you've got a Mac or Linux, it should already just be there. And if you want to use your cloud machines, I made new Debian cloud machines. You'll see them called desktop, Debian 10 desktop. And those are ones that have a complete desktop, so you can easily use copy and paste in there. This is a better solution. So I'll just log in here and show you how it looks. Let me pop out the console with no VNC. And here we go. All right. And so you log in with the same credentials, Debian, and the same password we've been using. And then you've got a box with a web browser. So you can open the projects in here and just copy and paste inside the same machine. So you can copy and paste lines of code. And to get Python, you just open a command prompt in Python 3, and there it is. So that is the easiest way to get Python if you don't have a local Debian or Linux box. You can also run it on Windows, but anyway, this is another way to get there. And all right. So once you've done this one, where you've got Python running at all, then there's a couple of things here to know about strings and bytes and files, and then we'll do cryptography with it. Strings in Python 3 had me quite confused at first because it's very different than Python 2. Python 2 is English only, so it uses ASCII, 1 byte per character. And that is actually a terrible old thing. C uses that too, and I was used to thinking that way, but that's actually a terrible system because there are many other languages and many more characters, so expecting to fit a character in 1 byte is not correct. And Python 3 does what it should do, which is use Unicode. So I'll just use my local Mac here to do this. And so let me, all right. I probably already have this stuff. Maybe not. Let me just go make a directory. All right. So if I make a strings file, greet.py, and then I put in this code, it shows the reasons why everyone loves Python is it's very easy to do a lot of important things like string processing. So if I run so what this is going to do, it's going to define a string called greet, which is hello world, and print it. Then it's going to print the first 3 characters. All you do is use square brackets and a colon. So 0:3 means 0 up to but not including character 3. 3 to 6 is 3 up to but not including character 6. And -3 nothing means 3 from the end to the end. So it's very nice. And then you can do greet.find to find a character, and if it finds it, it'll give you the numerical location of that character. So now you can print the quotient before the comma here with greet:(A). So this is an easy way to parse strings. And just Python 3 greet. And there you see the whole string and various pieces of it being cut out. So that kind of string, it's very easy to work. And so now you can do a little bit of networking. Here's a program that sends text to my server, and then it echoes it back. So echo.py. This just connects to one of my servers on a port 10201. This is using raw sockets, the original old-fashioned way to connect to sockets on the internet. So you import a socket library, you create a socket object S, you connect, and then you print whatever comes back, up to 1024 characters. Then you send a string hello from Python and print whatever comes back. And this server will accept a connection, and whatever you send it, it will just echo it back. So that one there, echo. So there you see, that's what I said, and it echoes it back. So that's not any big surprise. But now, that just makes it possible for me to make a few challenges where you have to send some strings to my server. And here, you have to send a number and then add numbers. So you'll have to learn how to convert strings to numbers, which is pretty easy. And there's a little tutorial here to show you. And then here's how you do loops in Python. So you can just, range 3 is 0, 1, and 2, from 0 up to, but not including 3. And you can also refer to strings for C and cat. We'll just run the loop over and over for every letter in that string. So that's what loops through numbers and letters look like. So you got that. And then there's another challenge just to show that. And then the last thing I want to put in this little video is the one that I found most disorienting at first about Python, which is, of course, the way it handles ASCII and Unicode. So let me use Python 3 in interactive mode, the way we were using it yesterday. Just another easier way to do it if you have short things to do. And this will do. All right, so here, you can define a single character with \x. You can specify it by the ASCII code. So 41 is a capital A and 42 is a capital B, and there's FF. So I'll have 3 characters, but when you print it, it's A, B, and then this strange thing, a Y with an umlaut on it. And if you then print the individual characters, A sub 0 is A sub 1 is A, and A sub 2 is that thing with an umlaut. So that is very strange. And we can see the bytes that form this string by using the AEncode method. And we can see that even though I defined it as 4142FF, what actually went in was 4142 and then 2 bytes for the last character, C3BF. So when I saw this, I became very confused. This is very different than Python 2 or C, because it's Unicode. And so the way Unicode works is very much like IP version 4. You can have from 1 to 4 bytes encoding a character. ASCII is the original 127. From 0 to 127 is the old ASCII system, and for consistency, encodes that stuff with 1 byte, so ASCII characters remain 1 byte long. But if then there's a group of them that are 2 bytes, then there's a group that's 3 bytes and 4 bytes long, so there's a total of 2 million combinations, and those are called code points, and they encode all the different characters. So you can specify that with \u, but you must have all 4 bytes there, even if the first 3 are 0, and they will in fact not be stored. So this is how you define Unicode code points. And after I got used to it, this seemed much better. A string is a list of characters, and each character is a Unicode code point. And if you want a list of bytes, that's a byte array, which is a different object than a string. Thinking of strings as equal to byte arrays, the way they are in C and Python 2, is something I had to get over. So here's a few of these. All right, so if I do \x41, that's A. \u41 is not legal. You can't do it. It has to be all 4 bytes specified. So this one's also illegal. This one's also illegal. This one is a legal Unicode code point, but it stores as A, and it's only 1 byte long, 41. It ignores the zeros. So there's that one. And that's the point. It's just 41. So that's the game there. And so now this FF that I put in, we can begin to get some clue what happened there. So the FF itself prints as Y umlaut. This is not legal, and this is not legal, and that is not legal. And this is interpreted as Y umlaut, and somehow it does a translation from this not legal Unicode code point. That's not really a legal one. Somehow translate that to this legal one, C3BF. And I don't quite know how it does that instead of just throwing an error message. But it interprets that as this legal Unicode code point, which is the Y with an umlaut in it. So anyway, and there's a couple of challenges here about that to find some code points. So you can try that stuff if you like. Or of course, if you prefer to do anything else, there are these other challenges there. But that's my plan. Then we'll move on to this stuff after a little while. So stop that.